of the extreme weather events, hurricanes, floods, droughts, those increasingly frequent phenomena that are part of our climate-changing world. These pictures play out the passing of the seasons. You can see how the world's vegetation extends across land and sea, forming bands of growth that circle the earth. There are bands of ice in the polar regions, then bands of life, bands of desert follow, and then another band of life at the equator.
Planet Science.
The satellite instrument that made these measurements responds to
Planet Science.
During spring and summer, as the plants on land
The Science Museum.
and in the oceans thrive, the green chlorophyll.
Good for GCSE, Year 10 and Year 11.
Autumn and winter, the green chlorophyll dies away, and we see growing zones of brown. The timing of the seasons is just one way to observe our climate-changing world.
So can we go around and come back?
Satellite data can be combined with other sets of information. Here, satellite images of the continents have been combined with a computer-derived model of the ocean's currents. Studies like this are vital in gauging the effects of climate change on our planet. If we look carefully at these images, we can see how a strong equatorial current flows across the Pacific, through Indonesia, then on into the Indian Ocean, before moving around the southern tip of Africa. It then eddies and spirals, heading up to the Caribbean, where it creates the loop current. This loop is important in predicting hurricanes, but it's also where the Gulf Stream begins. This moves up the eastern seaboard of the United States, before heading across the North Atlantic toward the westernmost parts of North Europe, including Britain. If the changing climate affects the Gulf Stream, then average temperatures in the British Isles may become closer to those of Newfoundland in Canada. You're now looking at the flights of aircraft over a period of 24 hours. These pictures have been generated from the navigation satellite locations for each aircraft. The main air travel hubs of the continents are clearly visible. So too are more remote destinations in the middle oceans. We can see that most travel happens during the day, with flights tailing off at night. Aircraft, like cars, lorries, and many ships, burn fossil fuel and so emit greenhouse gases. It's unlikely we will stop flying, our society now depends on it, but it is likely we'll develop more efficient forms of aircraft, alongside new types of cars and shipping, to lessen the environmental impact of our transportation systems on our climate-changing world. We are part of this planet. Just as the natural features of Earth show up from space, so too do our own imprints. This visualization is compiled from several months' worth of satellite data and shows the electric lights on Earth. Areas of dense population are well illuminated. Many coastlines are highlighted too. People like to live by the water. The Nile River in Africa is outlined by the lights along its border. Major highways in America and Europe can be identified by the lights that string and crisscross the land. It takes huge amounts of electricity to power the world's lighting networks. These pictures raise issues such as how best to generate the electricity from dependent power. One thing seems clear. Satellite pictures of the future are likely to show an ever-increasing spread of lighting across the planet. And as the demand for power continues to grow, we will need to explore new ways of generating energy, which is both cheap and sustainable in our climate-changing world. Imagine you're an astronaut floating in the blackness of space and looking down on our world. This is what you'd see. A beautiful blue marble ocean, land and cloud, topped and tailed with ice and snow. This picture was composed from data collected by satellites way out in space. They orbit Earth, detecting and measuring, keeping an electronic eye on our world, revealing how it works, recording how it's changing. Covering every part of the planet, using astonishingly sensitive instruments and working continuously for years on end, satellites are immensely powerful tools that are helping scientists to understand our climate-changing world. Astronauts were the first people to see the clouds clearly from space. Today's advanced satellites reveal their intricate behaviors and patterns to us all. This sequence was recorded over the last few months, but it's been speeded up so you can see in seconds what's happened over days and weeks. Clouds are rising from the equator, where the sun's energy is strongest. In the mid-latitudes, between the equator and the poles, you can see vast low-pressure systems, some of them storms, spiraling and swirling their waves across the oceans before weakening the land. These pictures help us forecast the weather, but over the years also provide historical records of the extreme weather events, hurricanes, floods, droughts, those increasingly frequent phenomena that are part of our climate-changing world. These pictures play out the passing of the seasons. You can see how the world's vegetation extends across land and sea, forming bands of growth that circle the Earth. There are bands of ice in the polar regions, then bands of life, bands of desert follow, and then another band of life at the equator. The satellite instrument that made these measurements responds to chlorophyll levels. During spring and summer, as the plants on land and phytoplankton in the oceans thrive, the green chlorophyll levels increase. Come autumn and winter, the green chlorophyll dies away, and we see growing zones of brown. The timing of the seasons is just one way to observe our climate-changing world. Satellite data can be combined with other sets of information. Here, satellite images of the continents have been combined with a computer-derived model of the ocean's currents. Studies like this are vital in gauging the effects of climate change on our planet. If we look carefully at these images, we can see how a strong equatorial current flows across the Pacific, through Indonesia, then on into the Indian Ocean, before moving around the southern tip of Africa. It then eddies and spirals, heading up to the Caribbean, where it creates the loop current. This loop is important in predicting hurricanes, but it's also where the Gulf Stream begins. This moves up the eastern seaboard of the United States, before heading across the North Atlantic to warm the westernmost parts of North Europe, including Britain. If the changing climate affects the Gulf Stream, then average temperatures in the British Isles may become closer to those of Newfoundland and Canada.